No, no.
Alright. So, who wants to go first?
I'll go
Ladies
first.
first. Abdul. I say Abdul. I mean, Mum.
This boy. What are the difference between scalar and vector forces?
Yep.
Vector has direction.
Yep.
Fuck, I got my tweets 1 second. I don't know who the hooker is.
Hold on. We're going one by one. Don't speed run it.
Oh, sorry. I thought you were doing it. I thought you were trying to catch up. Sorry.
No.
Bumping
We
against
just
it.
started. Alright, first one. Go on.
Me?
Yeah.
Vector has direction.
Yep.
Scalar doesn't.
Yeah. Scalar has magnitude only. Vector measures magnitude and direction.
Yeah, basically that.
Number 2. What is Hooke's law? Adam.
I don't know.
Samuel.
Who's
So
Hook?
slow.
Yeah.
Gee, ask Captain Hook. I don't know.
Alright, beg it, bro.
Can I guess? Can you give us a clue? And then I'll guess.
It's to do with extension and that.
Extension equals in and 4.
No. It's
On my line, on my credit.
force is directly proportional to extension.
I'm coming.
Yo, I was actually close, you know. I said 4.
Let's get one law from each of you. Who wants to do the first law?
Me.
Go on.
No, money.
Me.
Simple version.
Let Adam go for the simple one, innit? Because I just.
What?
I need the simple definition.
Alright.
I got one.
It's like
One
one word
word.
answer.
I'll do
apart from
the
the third
second
one.
law. I'll do second law.
Alright.
One of them is inertia.
Inertia. That's the first law. Yes.
Oh, what? Are they all
Second
one word?
one.
Number 2, Samuel.
One word. Bro, I don't know one word. All I know is acceleration is
Mass move.
directly proportional to phase. So result in force.
Force equals mass times acceleration.
Fuck,
The third one is a force acting on an object will like result in same force both ways.
Every object has an equal but opposite reaction.
Yeah, that one. Oh no. Alright, go on. Next question.
Alright,
What
what
does-
does the conservation of momentum state?
Fuck off.
Don't beat your shit too hard. I don't know.
Oh my god.
Sorry, bro.
Adam,
What?
conservation of momentum.
I'm gonna go eat now. Goodbye, Pablo.
Goodbye.
And everyone else.
The momentum before collision is the same as momentum after collision. See that?
Alright, no need to get that hyped up.
I just love physics. Oh my god.
Okay. Last one, triple. So, Adam.
Levels and gears. I don't know.
Come on.
To like, I don't know.
It's something to do with moments.
To, I don't know.
To transmit the turning effect of a force or a moment.
Oh,
Yeah, bro. So now that we got starter out the way, let's go through the basics. Are we ready? Bishlebu.
boom.
Alright, so as we went through in the starter, scalar has magnitude, vector has magnitude and direction. So, I am going to go through some forces and you have to tell me if they are scalar or vector. You ready?
Okay.
Alright, let's start with velocity.
Where's Sam gone? That is vector.
And what's So what would be the speed version of velocity? Oh, I just said it.
Hey boy. Yeah, cold.
Okay. So what about distance? Adam.
That is scalar.
Yep. Acceleration.
Vector.
Mass.
Scalar.
Force.
Vector.
Momentum.
I don't know.
You got a 50-50 chance.
Vector.
Yes. Alright, see, you do know. Then we have non-contact and non-contact forces. What are those?
I don't know. Contact force is a force where like you're physically touching, and a non-contact force is where like you're not touching.
I thought you didn't know.
Of course, I was joking.
Alright. Give me some examples of contact and non-contact.
Contact. Contact force would be. What the hell?
Think cause.
Friction.
Friction. You could also have air resistance, tension, normal contact.
Blah 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 blah.
What about non-contact?
Magnetism.
Magnetism, gravity,
Bashing D.
electrostatic.
And bashing D.
No. Gravity. What's gravity? What's gravity?
An inward force.
An inwards force acting upon a planet, yeah.
Bashing D.
No.
Oh man, there's someone saying that in my head, and I can't get it out.
What is a resultant force?
The total force acting on an object.
Yes.
Yeah.
How would be able to show this?
What?
How are we able to show a resultant force on a like a graph or a piece of paper?
What's that thing called again? The thing no one's on about.
Yeah.
Free body.
Free body diagrams, yes. So say there was an airplane, right? And it was flying forwards at 120 newtons, and there was air resistance of 90 newtons. Which way would it be going, and by how much?
What?
Oh my! Listen, yeah. There's a plane.
I'm listening.
There's a plane. It's going forward at 120 newtons,
Yeah.
and the air resistance is 90 newtons.
Yeah.
So that's backwards. So which way would it be going, and by how much?
It would be going forward by 30 newtons.
No,
Or is it the other way around?
it would be going forward at 30,000 newtons.
30. Oh, bro, you didn't say 1,000.
I did.
No, you didn't.
Oh, I did. You just weren't listening.
In another life.
What is the equation for work done?
Bashing it.
It's not that, I promise you.
No.
Really, you're not energetic today.
How am I not energetic?
Work done is equal to force times distance.
I don't get why you ask us equations. Because
Because
like
the people
we're
who
gonna get
remember the equations just remember everything else as well. Like, what if you get a question like, actually, no, I can't think of anything right now.
Bashing it.
No. So what is work done?
Balashibly. No, I'm joking. Work done is like, bro, the total energy used, isn't it? Energy transferred.
No, that's energy transferred.
Then work done is like
The amount of energy done.
the amount of energy done or the amount of energy that's said back in it.
How much work is done.
How much work is
Food.
bashing
Force
it.
is an elasticity.
No, sorry.
So,
No, sorry.
an object.
Yo,
Yo,
we seen
we're saying so, man.
But where's Sam gone?
you good, man?
Yo,
Try to start
right.
here.
yeah.
What is it? Mohammed, I only got 1 day, bro. Stop.
Bro, I promise you it's not my phone.
One day,
Oh
what do you
my
mean?
goodness. Till PS4 goes off.
Oh
innit?
yeah. Let's play last day.
What is that for every PS4?
Yes.
Yeah.
No way. So what are PS4 users gonna play now?
But I think it's like offline games and stuff.
Yeah, story
Oh
games.
my god. So now it's either get a PS5 or just don't play anything.
Yeah.
Yeah, man.
I was low-key dead.
Yo, that is peak.
We should sell up a fundraiser for Salman.
How many people in our year play on PS4, bro?
You're trying to call me poor, fam. What's this about?
Bro, I've asked you like bare times, when are you gonna get a PS5? You keep saying, like, remember you said your parents you said you're gonna get after the first mock, then the second mock, then the third mock, and now they say after GCSEs. Bro, you're never gonna.
Yeah, you're trying to shit then,
Yeah, because
innit?
they want them to focus on school, innit? Obviously, don't be stupid.
Yeah, but they're saying, oh, you get this reward if you do this, but he does it anyway, and he still doesn't get that reward. So it's unfulfilling.
Obviously, they're just leading it up to their big reward, isn't it?
The big reward.
Yeah.
Yeah, what's the point? I'm not gonna have any time.
Exactly.
No,
Everyone,
after GCSEs, you got better time.
everyone he knows, like, they're not gonna be playing anymore, are they?
I'll be playing. Then we come everyone as much as you like.
Oh my days.
All right, Salman, have a go.
Yeah. What's the difference? So scalar is magnitude only, and vector is magnitude and direction.
My God, have you been reading the slides? Smart guy.
That's not that hard.
What's his name? Farhan didn't get it, so.
What's Hooke's law? I'm not sure on that one.
Force is directly proportional to extension.
All right. What are Newton's laws of motion? So I think something is inversely proportional to something.
What?
Yeah.
No.
So you know, there's
Simple
like
definition. The first one can be that one word,
resultant force.
begin with the I.
So wait. What's the second letter?
N.
What's the third letter?
E.
What's the fourth letter?
Can't give you that.
Inertia.
Yes. First one's inertia.
What does that mean?
An object that stays at rest stays at rest. So if you don't move, you don't move. But if you
Also,
if you're
basically,
pushed by
no,
a
listen.
force, then you move.
So if there's no resultant force, then it will stay at zero.
An object remains at rest unless acted upon by a force.
Yeah, what I just said. Yeah.
So if Adam punches you, a force is being
Why would I
applied.
ever do that?
Yeah,
Are you right in the head?
A force is being
Why would I
applied.
ever do that? Are you right in the
yeah,
head?
do that, bro.
A force is applied to make you move. But if he doesn't
No,
punch
I
you,
don't like
then,
that
then you
scenario.
stay still.
All right.
All right, second one. It's an equation.
I think it.
Is it momentum or something?
No. The other
Oh, I
one.
give up. I give up.
Force equals mass times acceleration, bro.
Yeah, the mass is inversely proportional to acceleration.
It's not.
What's the third one?
Yeah, what's the third one?
Yeah, what is it?
Every object has an equal but opposite reaction.
That's basically what I said.
You never even answered the third one.
All right. Let's. What does the conservation of momentum state? Bro, I don't know anything about forces. It's a long topic.
It is long, but like, think of conservation in like chemistry. What like conservation of mass? Like the mass stays same after and before in it. So what's momentum?
So basically, so the momentum before equals the momentum after.
Perfect.
Perfecto.
Levers and gears. I don't know that one.
Transmit the turning effect of a force.
No. That's so long.
I know. All right. We were on this. So, when we're talking about elasticity, an object can either be compressed, it can be stretched, or it can be bent. But when it's stretched too much, what can happen to it?
Inelastically deformed.
Inelastically deformed. And what does that mean?
I have no idea.
What did No say? Remember last time?
I can't remember.
He used that keyword.
Basically, it never returns to its original
It
position.
never returns to its original shape because something to do with the forces. He mentioned the forces. Adam? It's when the forces are removed.
All right.
So then it goes past its limit of proportionality,
All right.
which is basically an elastic deformation point.
All right.
Then we have Hooke's law, which was in the starter. You guys didn't know what Hooke's law was. So Hooke's law is force equals spring constant times extension. F equals KE, where F is directly proportional to E. Basically, when you increase the force, the extension also increases. Like if I stretch a spring using a force, like the greater the force I pull it with, the greater the extension is going to be, obviously.
Yeah, man.
So we can do a practical on this, the pulley practical. How does that work? Anyone?
What room is English tomorrow?
3, I think. I'm not going though.
Oh, forget that of Mr. Ellis.
Yeah. So the practical is really easy. You just put some weights on the spring. It goes down. You measure the extension. You do it 10 times. Repeat. Calculate a mean. What's the safety on that?
What was that, bro?
What's the safety, bro?
I don't know.
Safety of what?
The extension practical, like the ones where you put the masses on the spring.
Keep feet away,
Keep the feet away. Why?
so the masses don't drop on it.
Yes. And how is the graph gonna look like?
Like directly proportional,
Yeah, but what's the line gonna look like?
straight.
Straight, yeah, because it's directly proportional. Physics only, triple only, but that's alright because we're all triple here.
Yes, only like 3 of us, bro. What do you mean all?
It's alright.
Come on,
So-
teach.
A moment. What is a moment?
A moment is, I don't know.
Come on. It's turning effect. Do you not remember Miss turning the door, Miss turning the... What else did she turn? A pencil or something?
No.
Yeah, she turned the door handle. She turned the... Let me give my own example.
I was going to say something stupid.
Why would I say something stupid? I was gonna say like
Okay, go on.
what's that thing? A wrench or something, and then you got
Bashing Nick.
a wrench and a pivot, and like you use the wrench to like turn it and stuff.
Alright.
Or it can be, what do you turn in everyday life? You don't turn a lot of things, do you?
A door, you open it, innit?
Yeah, we've already said a door.
You open it like a lid.
Oh yeah, like a jar or something.
Jar Jar Binks.
Jar Jar Binks,
Open a
yeah.
bottle.
Do you even know who that is?
Yes.
Who?
Who's the guy from Star Wars?
Oh, you do know. Smart guy. So, a moment. What's the equation for that?
Force times distance.
Force times the distance. But the distance, be specific on that.
What do you mean?
Perpendicular distance. It needs to be perpendicular to the pivot.
Oh, am I right?
Yeah.
Wait, what is it? Force times perpendicular distance.
Perpendicular distance, yeah.
Oh, you know, I guessed that.
So, to measure that, you need to go from the pivot to the thing you're measuring. Measure that distance. And then measure the moment. No, that's how you measure the moment, sorry. The distance and the force you're putting on it.
Alright.
So that's that. Then let's move on to... can skip the seesaw. Actually, no, let's do a seesaw. So we've got the seesaw example. Yeah, say you're on a seesaw. Let's get a picture of a seesaw.
Seesaw. Next to the seashore.
Where's a good picture? So, we got a seesaw here, yeah?
Where?
Right here.
Oh yeah, that's my boys. What the hell?
That's your boys.
Yeah, Ting and Tush.
What's the names?
Ting and Tush.
Oh my days.
Derek
sick
and
names.
Lily.
I know, bro.
Alright, so, as we can see, let's say these two were the same distance out, right? But she's higher. Why is she higher? What's so special about this guy that makes her go higher than this guy?
He's fat.
Peter just said it.
Thank you.
Yeah, so what is it then?
What are you on about?
This girl, she goes in the air, but they're the same
Yeah.
distance. So what other factor makes her go in the air?
The guy's weight.
The guy's weight, the guy's mass. Yeah, the guy weighs more. So then
He's bare
he's exerting a greater force on there. So
Your tongue is back.
how could she make the seesaw equal?
You can get bare fat.
No.
You can I don't know. Exert a force onto it.
She could,
No.
She could eat both.
The moment it's
Slide down.
generated-
Oh, she
slide
can,
down, yeah,
like-
get closer to the pivot. If she gets closer to the pivot, the distance between her and the pivot is going to increase, which means decrease, which means that the moment's going to increase, which means it's going to be the same as the boy, so it's going to be equal.
Boy.
No, she has to move away from the seesaw.
Wrong.
How's that wrong?
It just is.
No, it's not. He's stupid.
No, it's not. Wait.
She has to move away from me, you flipping idiot.
Either she moves
What was
away.
the question?
Either she moves away or he moves further. Yeah, because if he moves further, yeah, my bad, my bad. If he moves further, then the distance is gonna decrease.
Don't ever call me wrong in
The
your life,
distance
yeah?
is gonna decrease, and it's gonna match the moment of this girl, which makes it equal. But if she goes there, then the distance is gonna increase, and the moment is gonna increase as well. Yes, it's gonna increase as well, which means she's gonna go like bow, and then they're both gonna be equal.
No, she's not.
Go like,
What's she gonna do like then?
ow. She's gonna go like.
All right, that's
ow.
that example. Then let's go to gears.
Yo, tell that guy to shush,
Like
man.
gears.
Tell who?
They say
Who do you
gears,
think?
Like a gear.
Fetch cool.
What?
As you know. Uh, let's just use this one. It's really matter. Oh, it's. All right, so we've got two gears here.
Yeah.
Tell me
Two
what
gays?
gears.
Oh, yeah.
Let's say this one's A and this one's B.
Yeah.
Tell me what's happening.
Gear A is moving 2 times faster than. Is rotating 2 times more than
Gear
gear B.
No, gear B is 2 times.
Gear B is 2 times. Can you not see?
Wait, which
Thi-
one is gear B?
This one's A, this one's B.
Wait, A is the green one.
Yeah.
Ah, bro, did I know that?
Yeah, because I told you.
Yeah, I wasn't looking.
And you still said, yeah.
Oh, mate. Bro, obviously you know what I meant.
Oh, he's right. Either way, he got it wrong. Mixed up in it.
Yeah, yeah.
Exactly.
So this one goes at a 2 times speed. Why?
Because it's
Because
smaller.
it's smaller.
It's smaller, yeah. So for every rotation this does 2 times that rotation.
Thank you.
I get you.
So as you can see, like it fits like in both holes, innit? Like at a greater speed, innit? This has
Yeah.
this has half of. Does it? No, this has half of what this has. So it moves at a faster
Oh,
pace.
thank you.
So this is another example of transmitting the turning effect of a force, just like levers do.
What if?
Wait, no, we didn't go through levers, did we?
What if they're the same size?
Yeah, sure.
Then they both move at the same speed, innit? Actually, we kind of did go through levers, didn't we? Oh, what is that, bro? No, it's not.
How do you know that?
No, I don't know that. Alright, then we got this guy here, yeah? Who's
Oh,
this
that's
guy?
my boy.
Jamal.
It's not Jamal.
Yeah, true. Jack.
That's
Who's that? Tony.
Tony. Who's Tony?
Tony. That's Tony and Leash.
Oh my god. So, I don't know why he's lifting it. He's supposed to be pushing down.
He's not lifting it.
It looks like he's lifting it.
Well, you need some new eyes because he's pushing it down.
Well, no, if he was pushing it down, then his hand would be on top, not underneath.
Obviously, he's just putting it down carefully, innit?
Why would he push it down with his fingers when it's so heavy?
But do you know how strong Tony and Leash is?
He doesn't look strong. Look at his arms, bro. Look at his legs.
Yeah, have you ever heard of a sleeper build?
Sleep well. That's what Ishmael has.
Ishmael. Ishmael.
One of his arms is like
Short.
lots of muscle. The other arm's just skinny.
That's not a sleeper build. That's just like
He
one
calls it a
arm.
sleeper build.
That's not sleeper build. That's just what happens when you're goon too much.
Should you tell him that?
What if one of his arms is bigger than the other one? I'm pretty sure it's obvious.
Yeah, maybe he's doing curls in one and not the other.
Well, I don't
No.
Alright, so this is at a shorter distance than this, but he's at a longer distance. So, to transmit the turning effect, he has to put more force down. Kind of did this with the seesaw, didn't we? Fair enough, fair enough, fair enough.
I am coming over also.
Who is listening to that?
That's my brother. What are you watching, bro?
No, because I
You
saw
wanna build a
what
snowman?
you were talking about.
Not really.
Scammer hambas engading. Macam balak ke dasimble. Scammer day. Scammer
I
day.
think that's enough.
We used to be best buddies, but now we're not. I wish you could tell me why.
I think you should start on Frozen. Live action.
Live action.
I'm already in it.
Well, Miles Morales again.
No. What's his name? I'm Olaf.
You're Olaf.
Yeah.
Bro, you sure?
Yeah, I had to crouch down there.
Like Ishma.
There.
Ishma.
Yeah.
Ishma.
Yeah, but you're a tall guy. How are you gonna crouch that small?
Bro, you don't know I've got strong legs. I can crouch down for a long amount of time.
So you don't want to be that prince guy.
Nah. He's white.
So? Oh, Olaf is white.
Yeah, but it's a costume, mate.
Yeah, he's,
You actually thought they turned me into a snowman. Are you right?
yeah. So what if he's white? There can be a black one.
No, they can't, sorry.
No, have you seen the new Harry Potter series? They made Snape black.
Yeah, they're making everyone black. I don't know why.
I don't know.
I don't know.
I mean, it's
I
not
only
bad.
heard they're making
It's
a
not
white
like it's a
Black
bad
Panther.
thing, but like,
I mean, it's not a bad thing, but like, why not just keep it like how it is in the flipping original?
but that's like saying if you like cast a white actor to be Black Panther, that doesn't make sense.
Apparently, they are doing it.
They shouldn't, because the Black Panther's from Africa. There's no white person from Africa.
You've got South Africans.
No, but they're from Wakanda. All Wakandans are black.
Yeah, I don't know.
You don't know.
So they just race swap characters that their race doesn't make up their personality.
No, but that's just. I don't know how to feel about that.
So what if they made War Machine white? That'd be fine.
That'll be fine because he's American.
Oh yeah.
But then there wouldn't be a black Iron Man, so people are gonna be like, "Oh, where's the black Iron Man? There's a black Captain America. So where's the black Iron Man?"
But that's not Black Captain America. It's flipping the Falcon.
It's not the Falcon. It's Captain America, bro.
Yeah, but he was the Falcon.
He was the
before, so
Falcon,
it's
but
not-
there's a new Falcon now.
Yeah, but it's not race swapping because the Falcon turns into Captain America in the comics, so it's not really a problem.
Yeah, and he's Captain America now. In Doomsday, he is Captain America.
Yeah, but he was, bro. In my heart, he's still the Falcon.
In your heart. In my
Yeah,
heart.
because what Captain America has wings?
That's a sick upgrade.
Nope, because he's the Falcon.
Like, could Steve Rogers really beat Red Hulk?
No. Yes.
No one could. No Captain America could.
No, Sam did.
No, he didn't beat him. He was just.
He used his feelings. That's something Steve Rogers doesn't
That's
have.
not how you beat someone in a fight.
Sam has feelings. Like, he has that emotional impact on people.
He doesn't have it on me.
Is that why you're in Spider-Man and not in Captain America?
Of course, bro.
Oh my god. So I'm
Talking
seeing
me
you on
out
the big
of
screens,
fight
yeah?
does not work.
I'm seeing
Huh?
you on the big screens on July 31st. Spider-Man
Yes,
Batman.
you are. Yes.
I'm gonna go cinema. I'm gonna ask the employee. Yo, is there?
Why
is there a-
would you ask the employee? They've got no idea what's going on in the movie.
All right, I'm gonna ask the employee. Am I gonna be surprised? Is there someone from Derby in this movie? If they give me
And
that,
they're gonna say, I don't know. Why don't you just watch the movie, dickhead?
no, they're gonna give me a look. They're gonna be like, maybe I don't know. Then I'm gonna watch the movie. No, you're not gonna be in it.
No, they're gonna say, I don't know. Let's find out. And then they're watching the movie, and then they're gonna see me and gonna be, oh shit, I know him. I used to see him in town.
They're not gonna say that. I promise you.
Yes, they are.
Because you're not gonna be in it. They wouldn't hire such a like low like you've got no experience. They wouldn't.
Excuse me.
They wouldn't hire anyone.
I
with no
don't think
acting
you know how
experience.
long I've been acting.
How long have you been acting for?
Since 3.
A second.
What characters?
3 years old, I've been acting.
What characters have you played?
I'll show you after this, innit?
Okay. Should we keep going?
Yep.
Alright. Pressure. What's pressure?
Pressure? What pressure?
Pressure? What pressure?
Yeah,
Pressure's
shush.
for English.
Who's that? Oh my god. So pressure.
Pressure.
So what are the factors? The weight of the water above, the height, the gravitational field strength, and the density. All those increase the pressure.
Density.
What's upthrust, Adam?
An upward force, isn't it?
A what?
An upward force.
I added
Link
that.
it to the. You're doing the bare minimum, bro.
Up thrust is an upward force that pushes things upwards.
No, bro, even my brother could answer that. Answer.
Go on and get him to answer
Answer
it.
in terms of the water.
A
Upthrust-
resultant upward force exerted by fluids on submerged objects caused by higher pressure at the bottom than the top. Are you happy now?
No, because he's read off the thing.
I didn't read nothing, bro.
Yes, you did.
No, you got no proof.
Right here. A partially or submerged object experiences a greater pressure at the bottom surface. than
Well, I didn't read off there.
Oh, Google that.
No,
Oh,
no,
yeah?
no, no.
Google.
Nuh-uh.
So then, why does a potato sink?
Potato.
Yeah, why does it sink?
Because it's a potato.
No, explain it in detail. But what are we doing?
Because it's heavy.
I don't know.
My God.
Its weight is more. Its weight is more than the pressure.
Yes, the weight of the potato. No, yeah, the weight of the potato is more than the weight of the water, so it displaces it.
No, it's not. Are you stupid?
It's not.
No, the
How can
density.
the weight
the
of the
density.
potato be more? So you're telling me a potato weighs more than all of the water, yeah?
The density of the potato is more than the water.
Okay, but what about coins?
No, it's not.
Yes, it is.
The weight is greater than the upthrust.
Bro, potato is a solid.
Yeah?
It's in a fluid. Fluids are less dense than solids. So
all
therefore,
this yap. You don't know what you're
solids
talking
are
about.
more dense. So solids sink towards the bottom.
So how come potato doesn't sink?
Potato does sink.
No. I've seen floating potatoes before.
Bro, this is the exact
Hey.
question that Miss put in the lesson.
But
So
what
you're telling me you've never seen a potato float?
Let's search up right now. Do potatoes float or sink? Oh,
Exactly.
wait.
Nah, I don't want to hear no weight.
It's both.
I hate when you try to argue with me and then you get proven wrong.
Wait,
Depends.
it depends on the potato.
No, depends
Oh
on
no,
how
it doesn't
the
depend on the
water is.
potato.
Yes, it does.
It depends.
It
It
how
depends on the water.
is.
See, look at this one.
Are you
What am I looking at?
Can you not see it? Oh yeah, look. This is an apple. It floats. This is a potato. It sinks. This is wood. It
That's a
floats.
potato. That's a potato,
That's a
mate.
potato.
Yes,
That's an apple.
that's a potato.
That's an apple, bro.
That's a potato. I know you're trying to argue with me, but just calm down. That's a potato.
No. That's an apple.
That's a
That's
potato.
an apple. That's an apple.
I don't know if you learnt your fruits and vegetables as a kid, but I promise you that's a potato.
I promise you, that's an apple.
I promise you that's a
Salmon,
potato.
is it
That's an
potato or
apple.
apple?
Yeah, Salmon's gone.
Is
Bro,
he?
that's an apple.
Since when? Who else is in here?
Since he saw you call that a potato, I mean an apple.
It is a potato.
It's an apple. Yeah, it is a potato.
No,
Yeah, thanks. I know.
it's an apple.
Nope,
Bro, that's an apple.
that's
Let's
a
leave it to the
potato.
GC then.
Bro,
Oh, bro, just teach, bro.
Oh, Simon, is this a potato or apple?
What? Where?
bro.
A.
It's an
I can't see it.
apple, bro. Look at it, bro.
Hey,
wouldn't
that's an
look-
apple.
You wouldn't.
Exactly.
You wouldn't
No,
look
it's
at
potato.
it.
It's an.
Where you get potato from?
Where's he getting potato from?
From
Bro,
the
you
picture.
wouldn't look,
Picture?
Potato. Bro, you wouldn't
The
look
picture.
At potato and say it's an apple. Oh yeah, I just saw this mango. It looked like
Oh,
mango.
someone told this guy to shush. How do you
Oh,
deal with
yeah,
that every single revision
I
session?
feel like this grape here.
Distance time graphs. We don't need to know that. That's boring.
We don't.
Acceleration. No, atmospheric pressure. Oh my god, I almost forgot. So, when you get higher, in the Earth's atmosphere, does pressure get higher or does pressure get more dense or less dense?
More than.
Yeah, because there's more collisions.
Yeah, thank you.
So it's more.
Yeah.
Oh.
Yeah.
Forces of motion. Describing motion along the line. Speed. Acceleration. Where's acceleration? What is the typical walking speed of a human?
10 miles per hour.
No.
5 miles per hour.
No.
6 miles per hour.
No.
2 miles per hour.
No.
20 miles
1.5.
per hour.
1.5. Thank you.
Oh, 1.5 is it?
1.5 miles an hour.
Yeah. Second.
Who's walking that slow?
What about running? Running speed?
6 miles per hour.
No.
10
5
10.
miles per hour.
10.
No.
7.
No.
8.
No.
12.
No.
7.5.
No.
15.
No.
16.
No.
17.
No.
9.
No.
4.
No.
3.
No. Yes.
3.
Yeah.
Oh, what?
What the flip?
And
You
then
lot are
cycling.
so-
And then cycling.
Oh, who needs to know all of that?
They can ask you this in the exam.
They're not going to ask you that.
They can. It's on the specification.
Yeah, but they're not.
What's the cycling speed?
I think it's like 10.
No.
Yeah.
15.
If the first one was 1.5, the second was 3.
4.5.
No, you times it by 2, so then
6.
6. Yeah, that's what it says on the specification. Walking is 1.5, running is 3, and then cycling is 6.
That's some bullshit.
What is the speed of sound in air?
3.5.
Speed of sound.
20.
330 meters per second.
Yes.
50 miles per hour.
Velocity is just speed with distance. So say I say Timmy runs.
Yes, sir.
Half a marathon.
Say I say Timmy runs
Yes, sir.
Half a marathon.
30 meter, no, a 50 meter race. Is that scalar or is it vector?
Vector.
No.
Second.
Scalar.
Yes, because I'm just talking about magnitude. I never gave you a direction.
Oh, thank you.
What if I say Timmy runs 50 meters in 10 seconds?
Then that is
No, it's still scalar, bro.
3.1.
I just added the time. Time is not distance. Time is not direction.
I gone.
Alright, and then say I say Timmy ran a race, a 50 meter race at 5 miles an hour going forwards.
Velocity.
That is vector.
It's vector.
Yeah, velocity.
Yeah, velocity.
Velocity.
So what is velocity?
The
A
speed in
change.
a given direction.
The rate
Wow.
of change. The rate of change of. We know.
Speed in a given
Speed
direction.
in a given direction. Yeah.
Yes.
So
Challenge.
so let's take this knowledge and put it towards. No, we'll do that later. Acceleration. What's acceleration?
Your mom.
Rate of change of velocity.
Yes, that was fast.
Yes.
Yeah, because I've got a high velocity. You get that.
Oh my god. So, say Timmy accelerates
Why are we always using Timmy as an example?
because Timmy
I
runs
say
fast,
Mohammed,
innit?
in it. He's faster.
Exactly.
Mohammed's not faster.
Yes,
Mohammed
I
is
am.
faster.
No,
I've been training.
we got the video to prove it.
Asher speed.
That was last year.
Exactly.
I'm faster now.
And you lost the year before as well. You said the same thing.
Yeah,
I've been
a year.
training now. I'm faster. Like I don't get what you don't understand.
Well, we can't prove it now, can we? There's no more sports.
Yes, we can. We can race when the field's open.
Oh yeah. So.
So and so and so and so.
What are the? No.
I don't know, mate.
Hold on. Hang on, I'm trying to think. Alright, so acceleration is that. How can we link acceleration and velocity to the moon orbiting the Earth?
So basically, the velocity is constant. And
No,
the acceleration.
no.
No. The acceleration is constant.
Nope.
Yep.
So what's constant?
So the moon, it's moving at the same speed.
Fly me to the moon.
That's what I
Let me
said.
play.
Hold on, no,
on the
you said
stars.
velocity.
Let me
Velocity is speed
bring
and
it my
direction.
star,
So hold on.
Jupiter and
You said
Mars.
velocity is constant. Velocity is not constant. Velocity is speed with direction. Speed is constant, but direction is not constant. It constantly changes directions every time it spins across the Earth. The moon spins and the thing spins as well. So when the
So
moon
what is it?
spins,
What's the answer?
so when the moon spins, right, the velocity changes. And what is acceleration, Mohammed?
Bashing it.
The rate of change of velocity.
Oh my days! You didn't even get me a chance to speak.
It's the rate of change of velocity.
Yeah, I know that, mate.
Aye, what's
So-
the answer then?
So I'm getting to it. So if we're changing velocity, that means
So
that we're
what does-
accelerating. That means the moon is constantly accelerating because
What
it's
did I
changing
say?
direction. Because it's
The moon is constantly accelerating.
Yup.
What else?
because
Because it's constantly changing velocity.
yes,
okay,
and
okay.
velocity is the measure of speed and direction, and direction is always changing, but speed is not.
All right.
Speed.
Thank you, Pablo. You're so smart.
Oh, thank you. Appreciate it.
No, I was joking.
What the fuck?
Okay.
I'm not joking.
Oh, this is a nice one. What's terminal velocity?
The maximum velocity.
Reached by an object due to its resultant force, resistant
Bashing
force
it.
acting upon it. So let's use a parachutist as an example.
Yeah. Let's go.
Oh, all right. Let's use this guy. No,
I'm your son. I'm your dad. I'm your son.
This guy.
I'm your dad.
Let's use
no, let's use this guy.
Yeah,
no.
let's use-
All these guys.
Oh, that's my boy.
These guys all suck.
Oh, that's my boy as well.
That's not your boy.
Yes, it is.
what the fuck?
Quality is bad.
Oh, that's my boy as well.
That's not your boy.
Whoa.
How would you know?
Because everyone's your boy.
Exactly. So obviously it's my boy.
Oh. It's not your boy.
What's that? What?
Oh, that's too zoomed in.
What's that?
What is wrong with this guy?
Yeah, well, yeah, okay.
What's
Trust
that?
me.
Can he even
Alright.
hear us?
Yeah, no.
What the flip?
Let's go.
What? I said flip.
No, but like, you're talking.
So?
I don't talk when you're recording.
What does he record?
I don't even know.
We need to find out.
Right?
So,
So,
say Salman jumps out of a plane and he has a parachute. What's the first thing that Salman experiences?
air resistance.
Tablets.
Before air resistance.
Gravity.
No, it's weight.
Weight, yes. His weight is greater than the air resistance.
Yeah, but how is he? He's always experiencing weight.
What?
So how is he? Why is he only just experiencing it when he jumps out?
Okay, let me. Mm. You're pulling a tight one here.
Yo, Becca, I thought
Mate,
you got
I'm not putting a
80%.
no tight one. What are you talking about?
Just hold on. And I need to get
No.
a quick. Hold on. So I can explain this to you.
Yo,
Sounds like a real thing though.
Mashing
Can you stop saying that?
Does that sound like a real thing?
No.
Nah.
Oh, sorry.
It's okay.
No, it's not okay.
I forgive you.
I don't need your forgiveness.
Brother,
Ooh, cold line.
brother, please forgive me.
Do you know who said that?
Loki.
No, Mashing Dick.
Loki is good. Loki.
Wait, can I edit
Loki is
this? Wait. Hold on. So I need- This is a very important thing. You get me?
La boo boo. La boo la
Get a
boo
job.
la boo boo.
Why can't I write? Oh, I can't write. All right.
Get a job.
So, Saruman is.
Mashing Dick.
10 years old.
Forget this parachute. This parachute's not here, right?
How, bro? I can't just forget it.
Just
That's
forget
my
it, bro.
boy.
All right, we'll have another one here.
Just put the parachute in the bag.
So this guy.
Who is
guy-
that supposed
Oh,
to
what's
be?
wrong with you?
Just put the parachute in the bag.
You can't draw for your life, bro.
How? It's a stick man.
No, that's not sick, man.
How is that not a stick man?
What? Why is his head in the shape of a pistol?
Oh yeah, what is it then? What is it
What do you mean
then?
a pistol?
What is it then, man?
Bro, who's this guy talking to?
What
I
is
don't
it then?
So we got a stick man, yeah? That's Saruman. He just jumped out of a plane.
Yo, why are you violating
Just
someone?
listen! He jumped out of a
yeah.
plane.
Yeah.
Not you.
Paul, don't ever forget, I will kill you.
Exactly.
Listen, yeah, just use a ruler to underline your thing.
Yeah.
Your date.
Okay.
Watch that mouth, yeah?
Alright.
Maga Mohammed.
Of course, G.
So he jumped out of the plane. His weight is way greater than the air resistance. His weight is greater, right? The air resistance is only like this big.
Yeah, because he eats
His weight is
burgers.
greater, which means say this is 10 newtons and this is like 60 newtons. He's going downwards of 50 newtons. So
Are you calling me
he's-
fat now?
Just listen.
Yo, Pavel.
This happens
you
to
just wanna know
everyone.
some example.
This
What-
happens to everyone. Weight is not the same as mass. Mass is how we say you're fat. Weight is a force acting upon you. Weight is
Yeah, but
how you go down.
If you weigh more, if you got a bigger mass, you're gonna have a bigger weight.
Well, yeah.
So you calling him fat?
No.
Yes.
Any person, any object, no matter what, it experiences a greater weight than air resistance as soon as it
Wow.
goes out of the airplane.
Yeah, but you're saying his weight is gonna be 60 newtons when the average human is 30 newtons. So you're calling him 2 times fatter than the
Average
person.
human is 30 newtons.
Like when it jumps out of the airplane.
Where'd you get that fact from?
From Google.
YouTube short.
Oh, you're really pushing my buttons here, aren't you?
Fuck your buttons.
Hey yo.
Is it? Wait, why is
Hey
it not
yo.
working?
What?
Why is it not? Why is it not erasing? What is this?
I might just teach now.
I'm trying to teach, but this doesn't work. What the hell?
Look at this save.
Okay, that's not
Never
nice.
mind. Look at this save.
So, okay,
Look
there's
at this save.
3 newtons, and he is 30 newtons.
Mashing it.
So, how much newtons down is he? 27. He goes down, and he's not at terminal velocity. He accelerates because he's going down. He's accelerating. He's going down at a fast rate, isn't he?
Yes.
Yes. The forces are unbalanced. They're not balanced, are they?
Nope.
No, so there's a
no,
result
no,
of force.
There is a result of force downwards.
It's called bashing it.
But then, as he keeps going down, yeah, he hits more air particles. These are air particles, yeah?
Yeah, yeah.
He hits more of them on his way down.
Yes, yes.
So, now that has happened,
Air's
the
going
air resistance has
against him.
increased, and it's actually matched the same as the weight. Can you believe that?
Wow, that is amazing.
No.
It's good.
So- Weight was 30 newtons, and then air resistance is also 30 newtons. That's not 30. It's also 30 newtons. Can you believe that?
Yes.
No.
Exactly. He is, his forces are balanced. So
What
what
the
does that
flip?
mean? What does that mean on his movement?
Tell him to shut up.
He's moving at a constant velocity.
He's moving at a constant velocity. There is no resultant force.
So he's
The
bashing
rule
Nate.
is 0.
Yeah, it's zero. You're moving at zero. You're at constant velocity, Salman.
Why so
Wow.
surprised?
That's so cool.
There's no resultant force, Salman.
Yeah, why so surprised?
But then, this is where we get to the fun part. We don't have to draw this
How
out.
is this fun?
Because
Because
he opens his parachute. He decides, oh, you know what? I'm going to drop tilted towers. He opens
Oh,
his
then he
parachute.
experiences more air resistance because the surface area is greater.
He experiences more air resistance. Look at all these air particles hitting him, bro.
That's not air particles.
You try and draw air particles then.
Literally, just it's not hard to just click a dot. I don't know where you're in lines.
Yeah, but it doesn't look good.
Yes, it does. I look good. We look good. We all look good.
No.
Except for you.
Wow. So he opens the parachute. The surface area increases. So that means the air resistance increases.
The air?
The air resistance increases. So for the first time, the air resistance is actually greater
For the first time in forever.
than the weight. Say the weight is like that big. The weight's not that big. So the weight is probably like.
Exactly.
You want to go that way? No, because you said the average human is 6. No, 30.
Wow, there's obviously someone out there with 6'7".
6.7. Let's go with that.
No, 67.
What's the calling Salman fat now?
Yeah, because he is.
I said there's obviously someone out
No,
there.
but this
with
is Salman right
67.
here. This is Salman.
Yeah, but I said there's someone out there. I didn't
Yeah,
mean
but we're
Salman.
using Salman as an example.
Oh my days! Don't beg it. Put 30.
No, because it's less.
No, it's not. Why would the weight change?
More or less.
Why not?
It's the weight's not changing. The air resistance is just increasing. Flipping bashing day.
So this is 30, and then air resistance is like, oh, we can actually do it. We can.
Why you put Oh my days.
Oh yeah, Salman, you sure came to biology today. Mr. Wood was saying 6'7".
Yeah, well, bro, did you even learn anything?
Yeah, quadrats, bro. Do you know what a quadrat is?
Nope.
There you go. Me and Adam know what a quadrat is.
Belly.
Oh, what?
It's like that thing with bare squares in it, and
Bare
it's square
squares.
and the daisies.
Yes.
Oh, right.
So that means that there is a resultant force upwards of 37 newtons. The forces are unbalanced, and what happens to his movement?
It slows down.
Slows down or decelerates?
What was that?
No, we didn't talk about that. So then, as he slows down, he hits less and less and less air particles. He doesn't hit that many now.
No, I want air
So-
particles.
That means the air resistance decreases. So it's probably only like that big.
About
But,
that.
but,
butt cheeks.
this means it's also the same as weight. So weight was originally 30. So that means this goes back down to 30. The forces are balanced. It's a miracle. It's 0 newtons again.
Why
There's
is it
no
a
result- there's
miracle?
no result
What are you
of
trying to
force.
say?
There's no resultant force. So what does this finally mean?
That he is moving at a constant velocity.
Constant velocity, terminal velocity. That's correct.
Terminator.
No. Actually, that is a very good movie, to be fair. Like
I
a
know.
writing.
I was in it.
Oh my.
You're in everything at this point.
I'm joking. I wasn't in that one.
All right, so we finished that. Do you guys understand it now?
Yes.
Yes, we do.
W.
W's in the chat.
Probably should be a
Let's
teacher.
go over Newton's first law.
Oh, not this.
Teacher. But no, he wants to be an engineer.
So, let's take football for example. Today we were playing football, right?
Yes, and I scored all my
Today we're
pens.
playing Rocket League,
Yeah, apart
right?
from that one. What was it again?
No.
What? What the flip? What are you doing?
So, that was your reaction when you kicked the ball, yes?
Yes.
You know what? We're gonna use something else as an example.
Could this be an example? Look at my screen.
Hold on. Hold on.
Chocolate, yeah.
All right, can you see my screen?
No.
All right, so you see yourself, you're hitting the ball, yeah?
Oh, go, man.
Why is it?
Wait, what's going on?
All right.
Oh shit.
So
Yeah, let's go.
you're hitting the ball.
Yeah, and it went in. So.
Why can I not? Oh, that's annoying.
Oh, what a goal.
Oh, look at my little aura walk afterwards. Go.
Okay, I can't do anything like that. All right, that's fine. The ball is still. Wait.
Oh,
It's annoying.
shit.
Oh!
The ball.
Papa, what are
Oh
you
my
doing?
god, this takes. Oh my god. Hold on. It's not. Pause it. Pause it.
Maybe press the pause button in there.
Okay. Here we go. So you can see the ball right there.
Yes.
Yes.
And now you call
It's still. We can agree. It's still right. It's stationary.
Yes, you can. But
Stationary.
I'm about to change that.
You're about to change that. You're gonna use Newton's first law.
Of course, see,
The ball is at inertia.
I hit the ball at
It's not
exactly
moving. It's not moving.
55 newtons.
And then someone comes in the way, and then a force is exerted onto the ball.
And that's that's me.
Oh, go, man.
So yeah,
That is me.
That ball,
I'm
yeah.
just the goat.
it's exerted. The force is exerted. Look at that go.
And then it just goes in because no one on this earth is saving that.
It goes in, then it slows down. Let's take a look at another clip. This one.
Oh my god, this one's horrendous.
The ball is still. We can agree on that.
Yes.
Yes. Then a force comes and it's kicked.
Oh, what the flip is that?
Ishmael with two
And then it accidentally hits another set of balls. And then Timmy's in pain.
What a
Ishmael.
So it's still.
You are.
It's still.
Oh, no, that's
You
how
are.
ball works.
Yeah, but that's the law. That's the motion law. So that's the
How
first law.
ball works.
The object will remain at rest unless the force is acted upon it. The object only moves if the object is if the
If you
force
press-
is acted upon. Play
If
to
you, if you interact with it. Oh, but that's
So that was, for example, when Abdullahi and Adam hit the ball. It was very nice.
Hey, yo.
What do you mean, ayo? It was very nice, but it also proved this law. Second law is similar to the first law. I think we can use the football again. Force is equal to the mass times the acceleration of an object. So, we can use the football again.
Why don't we pull up your clip?
No, we don't need that.
Yes, we do.
Mine's not good.
I want to see it.
Why not use this button? Ooh.
Let me see it in it.
I don't have it on me.
Yes, you do. I've
Not-
seen it
Not
earlier
here,
today.
Not on my PC.
Yeah, so send it on your phone then.
PC baby.
CBA.
Oh, because you know your shit.
Phobia.
So, you have a mass.
So all I had to do.
Wallahi, you have a mass.
Bro, you
The
don't,
ball-
bro, I'm listening to the next one.
The ball has a mass.
No, it doesn't.
Yes, it does. So,
Everything has a mass.
you kick it.
And
Look
it
at that.
flies.
You kicked it, right?
Why do we keep using? Let's use your clip.
We don't need that.
Yes, we do.
Listen. You kicked it. The only reason it moved is because you used both force and the mass of your body to push it.
Yo, what's Patricia saying, bro?
Do we understand that?
No, I want to know what Patricia's saying.
Oh my days.
Oh yeah, power. Who's Nimra?
Oh my days,
Nimrod,
what?
there's a new one. I thought it was just Patricia and Timea, fam.
Stupid, dumb friends can't
I
understand.
power. Who is she?
Bear people.
No.
She's bad people.
Bad
No,
people
she's-
can't
What's
be friends.
what?
Powell. Who is she?
That boo-boo do what
Listen,
I
don't let me get
did,
my
yeah.
ruler.
Alright.
Abadum.
Alright. So second law of motion,
Abadum.
Is
force equals mass
Patricia and
times
Timea.
acceleration. We get that. Last law.
Easy.
Alright. Let's use. I should use this as an example. Yeah, we can use a rocket ship, I guess. Alright. Did you guys see the Artemis 2
Yes.
launch?
Nope.
You didn't see the Artemis 2 launch?
No. I was supposed to be on it, but I had to do a little shit
Oh
revision.
How they blow
So you
up
didn't see
the
this?
Abadum?
Nope.
Okay,
I just fake.
alright. So,
It's green screen.
as we can see, the rocket, there's a force that's going
Yep.
down. That force is making the rocket go up. That force and that force are equal because the force that is exerted here also has to be exerted here. That's Newton's third law.
When did you say that?
Another example, a gun. Technically that's momentum, but
Another
we can do it
example.
either.
My PC.
You know what recoil is, right?
Yeah.
So,
In your
when you-
power, you got recoil.
no mate. We
That's a compliment.
when we pull this trigger, a force is exerted on the bullet to go that way, but there's also recoil on the person that's shooting it that way. That's an equal but opposite reaction because this force exerted here is also this force exerted here. That's an equal but opposite reaction.
The stronger the weapon, the more recoil. And then, Paiku,
I don't even know what to say anymore.
the stronger the
Falco.
weapon,
So
the
we went
more
through all three
recoil.
laws. Perfect. Stopping distance. Let's see.
Law number 1.
Alright, let's take a car for example.
Your car.
Any car.
Let's take your car.
Adam, you see this car?
Oh my god. I used to have that car.
You used to have this car.
Yeah, back in the
then,
days.
So then you would know.
Honda S38.
No, it's not, mate.
What is it?
It's literally a Jaguar XF. It says it right there.
What is it actually? It's a Jaguar XF.
I just said that.
Oh, because you're on that thing.
My guy has no idea what that is.
So, so you said you were driving this then?
Of course.
It wasn't. That's a lie.
Okay.
Oh,
Would you say?
Yeah, what's the question?
Would you say you ever drank any alcohol or drugs?
I might have.
You might have.
Whoa.
Yeah.
So when you did that, did you think that was maybe like a distraction to the road?
I was locked in. I was in flow state.
Oh, well, some people they can be a bit aggressive.
Nah, I don't let alcohol get to me.
I'm not saying you. I'm just saying other people, innit? It's a distraction. Maybe there's a kid on the road, and then before they know it, they can't stop before they see him.
Yeah,
That's
thanks,
thinking
thanks,
distance.
thanks. Next question.
That's your thinking distance. What else can affect your thinking distance?
Seeing two
Um,
cars when there's only one.
Reaction time,
Yeah, your reaction time, but
your age.
your age,
Your vision.
thinking. What makes you stop thinking? Distractions. What other distractions are there?
If there's a girl outside,
The stop sign.
I mean,
if there's a girl right in front of your car,
why would that be a distraction?
because she's in your front of your car.
Okay. What distractions inside of the car? Maybe your belongings.
If like a bee gets inside.
Sure.
In your glove box.
But I was thinking like your phone. You might be distracted by your phone.
Oh yeah, if you get a message from Poku saying join the revision.
Yes, exactly.
What about the
Which is why you should put your phone on silent.
Or maybe just don't message me while I'm driving.
Wait, Paco, I have
You
an
can't
idea.
drive.
I have an idea.
You don't know
I
that?
know a distraction. The radio.
Yeah, sure.
That is not a distraction.
Bro, imagine you're there. And then.
Oh yeah,
Someone
here's another one.
Bro, just slap him already.
You just came back from school, innit? You played a lot of football, you used a lot of energy. What are you?
Energetic.
I'm a bashing dick.
You're tired.
What?
All these can affect your stopping distance, your thinking
What?
distance.
Thank you.
And then say you've had this car for a few years, you know, tires they're getting a bit old. What's a braking distance factor?
I
The
don't know.
condition of the road,
Condition of the road. Expand on that.
like, wait, how am I supposed to expand on that?
Like if it's wet, if it's icy.
Yeah. Condition of the tire and the
If
brake.
it's hot.
Yup. That all
If it's
Like
hot.
the tires are like all worn out.
worn out. Yep. Perfect.
The brakes are malfunctioning.
Let's move on to momentum.
God.
Let's go.
You feel so-
Oh my days, this guy's actually starting to piss me off.
With me?
Wow! This fat ball, like you, Pablo.
Momentum. What's momentum?
No idea.
Mass times velocity.
What's momentum?
Mass times velocity. So that would be when Adam was kicking the ball. He had a little run up, right? He had a little run up, and he used that momentum to kick the ball.
All right.
Let's use that as an example. He kicks the ball, right? His momentum before kicking the ball, let's say it was, what's it measured in? 50. Yeah. Let's say his momentum
Yeah.
before was 50, and then after he kicked the ball, what's the momentum of the ball going?
Sorry, what was the question?
So Adam,
Whoa.
before he kicks the ball,
Yeah.
his momentum's 50,
Yeah.
and then after he kicks the ball, what's the
Yeah.
momentum of the ball?
50.
50. Why?
Because the momentum before equals the momentum after.
Yeah, it's the conservation of momentum.
Yep.
Oh, that's raw everything. We finished the spec.
We finished it.
That was quick. Well, basically, yeah. Then the last thing's changing momentum, like seat belts, airbags, just any safety.
All right.
That was fast, you know. It was relatively fast. Where's Mohammed gone?
Alright, what lessons we got in the next few days then? What are you gonna teach?
Let me see. All right,
Are
we
you doing
got
history
tomorrow's history. Then it's Romeo and Juliet. Then it's
Yeah.
Islam. Then it's
Yeah.
computer science. And there's maths.
Maths. Alright. Maths. So April 9th and April 10th, April 12th. Alright.
So tomorrow, it's kind of just like rest day for you.
No fun.
I want you to
On a
work
rest days.
and work and work.
Oh, what are you gonna do now?
Past
You
paper
need
questions.
to get a job.
Alright.
You're fired from streaming on your flipping YouTube
This guy to shut his mouth.
because all you do is
What's wrong with him?
I don't know.
Oh, yeah.
And
Sounds like a
stupid
twat.
rewards. So you need to get off right now.
This guy's a dickhead.
Good boy.
Trust me.
Oh. Tell him to shush it.
All right. Physics.
Trust me. Trust me. Trust me. Come on. Trust me. Pass. Pass the ball. Pass the ball. Pass the doll. Pass the hour of joy. Pass the hour.
Oh, this guy's. Oh, it's pissing me off.
See?
PMO.
Because that's the hour of joy, in it.
No.
You survived the most.
Let's skip this one.
You survived
Okay, let's
the
do
most
this.
craziest hour of human
Where is
history.
Mohammed gone?
Oh, I don't know.
Just go. All right. Calculate the mean weight of a tomato in figure 1. Let's get the physics equation sheet up.
What's that question? Calculate the.
We need the paper 2 ones. Paper 2
Oh,
equations.
God.
That's paper 1.
I'm going like 10 minutes. I need to go pray.
What about PlayStation? It's the last day.
Yeah, later.
All right.
Just bell me in it.
Fair enough. Bro, where is...
Ishma. Where's Ishma? He's dead.
You hearing this
Who the
language?
Fuck is this guy on about?
Trust me.
Ishma's dead.
Who you on about, mate?
Ishma,
Who is Ishmael?
your friend.
What, Ishmael? Yeah, cold. So, we want to look for
Babylon.
these. It's only these.
We want to look for Babylon.
Wait, hold on. I'm reading something. Wait. Wait. Give me 1 second. Can you still hear me? What happened? Did I leave?
No, it was me.
Oh, no.
Alright, so... You got your equation?
Alright. Wait, give me just 1 second. Kasim sent me something. Wait.
That's a mushtaq.
All right. Yes.
Yes.
What was the question? What did it include? I can't really see that. It's a gravitational field strength.
Pass is short.
Gravitational field strength mean what's it? Wait, what you calculate the mean weight of a tomato in figure 1. Where's figure 1?
So what is that? 420.
That's mass. Is that weight or
425.
mass? What is that? Mass or weight?
It's grams.
Mass.
Mass, yeah.
So we have mass and gravitational field strength. Alright, go back. The mass and gravitational
It would be on
field.
this side. This paper two.
Okay. Alright, zoom in a bit. Oh, I see it. Weight equals mass times gravitational. So it's 425 times by 9.8.
So weight equals mass times gravitation for this strand.
Alright, I'm gonna go in 5 minutes.
Alright. So the weight, we don't have that, is equal to the mass, which is 425. Sorry, my 4 times 9.8. What's that?
What is it?
Pavel,
Yeah.
Pavel,
Hello.
are you on live?
Huh?
Are you on live?
Yeah.
Oh, Salman, you're gonna come tomorrow for English?
No.
You might want to.
Why?
Oh.
Oh,
Abed, message me.
Wait, how does he know?
Put two and two together, Pavel. Don't mention on stream how, but
Relax.
By the way, I think he got my rule yesterday.
Yeah, man.
Tomorrow. No, tomorrow.
Yeah.
Just give it back to me like Monday or something. Spring constant. So I already know this one. Force is equal to spring constant times extension. What's the force? Force is 6. Spring constant.
I'm just trying to find the exact message.
Wait, send it in the group chat.
I'm trying to find the exact message.
1.7.
wow.
Paul, just give me 1 minute. Ooh.
You're gonna consider it.
So, yeah.
Alright guys, I'm gonna end the stream there. Hope that was an eventful session. See you guys later.